Всем доброе утро. Рад приветствовать вас на нашем докладе. Я Евгений Полонский.
Hello, everyone. My name is Evgeny Polonsky. I secure Unix systems in Positive Technologies, and my co-speaker is over there. He is going to come soon, Vasily Brit, Python developer in Positive Technologies. Today, we'll be talking about supply chain attacks and how to arrange the supply chain of your software in a way that your customer is not the target of a hacker attack. So I believe that you all know what supply chain stands for. This is a process whereby the products find their way from the producer to the end user. And this goes through transportation, storage, sorting, and this can be in several cycles, depending on the distance this product is going to cover. More or less the same holds for software. And but from delivery, initial delivery, you need to build a supply chain for the software upgrades so that you can further support it. And the supply chain attack happens when the threat actor, well, anyone, can penetrate any chain or any part of this chain and modify the code or an artifact or the end product. This way, they will get access to the partner systems or the customer systems. And these attacks are especially big as a threat, because one attack will develop into 100 or even more attacks of those who buy the supplier's software. And the first target company will have a lot of financial and reputational risks, because people are not happy to pay for a product which is going to encrypt the whole of your infrastructure, demanding ransom. One of the highest profile attacks happened in 2020. It all started in spring, and it was discovered only in December. And the result of the attack on SolarWinds resulted, well, this attack resulted in modifying software, helping the company manage the networks. There they had the malicious code, which was further spread through updates to the partner companies. This bomb exploded in December, affecting up to 250 companies in the United States, including the government agencies like the Ministry of National Defense of the United States and large corporations like Microsoft, Intel, and Cisco. This slide gives you a simplified supply chain scheme and how it interacts with CI/CD. We start with the code repositories, then the versions control systems. Then all of that is built on the automated builders like TeamCity, Jenkins. Then it goes to the repository, all these built artifacts. So we go to the factories like JFrog. From the repositories, we can have a link to the build automation system. Since in the building process, you need to load dependencies, and these dependencies will be there in the repositories. Then the product is forwarded to the update servers and further delivered to the clients. Here you can see the popular tools, the ones used to store the code, GitHub, GitLab for the build, Well, GitLab CI, well, it is integrated into GitLab, and this way you can easily tune your build process. You edit one file in the repository, and there you just describe the build steps. This is easily done, and it has a thread hidden inside, since anyone who has the developer rights to edit and modify the code in the repository can edit this file, add there anything, and this way they will get access to the build agents. And there we have the code from the repositories provided by a developer or any school guy in Asia who is using the credential of the developer. So this can be tempered, and this way we can affect other repositories, branches, and even releases. To store the code, we can, to store the artifacts, we can use Syntax Nexus and artifactories. And we have one of important attacks, dependency confusion. It is pretty straightforward. To build the projects, we use libraries. They can be third-party ones. They can be available from the public repositories, and they can be private. They can be stored in the repositories inside the company. To upload these dependencies, they use so-called package managers. The loading process is pretty straightforward. You just say package manager, install, and give the name of the package and the version. In the Python, you can say pip install and the version title, and this package will be loaded from the repository you mentioned. And there can be several repositories available, and in the config of the package messenger you can see several repositories, and you can have both private reps and public reps. And what's going to happen if in the private or public rep you can see an artifact with the same title but different content? The package manager will look at both of them to download the version of the artifact with a later version. If you don't mention the specific version in the install config. This can be used if the hacker knows the title of a package. Maybe they get it from the manifests or maybe from the code. So if they know the title or the name of the package, understanding that this package is not available from the public repository, you can try to load a changed version with some payload to the public rep. And if the package manager in the company is set to pick the packages from the public and private reps, then they will take the later version from the public rep. And this will bring you the adversary's code. An attack like that can happen through the package managers. And we also have the artifactory. And there you can bring several reps together into one virtual rep. And this way you can merge a private and a public rep. And this way you can ask for a package with the title which is supposed to be in the private wrap only, but if the later version is available from the public wrap, then the public wrap version will be downloaded. Another kind of risk is the use of free software. We cannot be sure that the person developing the software isn't mad and is not adding malware to the product. You know, this happened in March this year. The developer of a popular package, not APC, protesting, just added to the code some malware which checks the APIs of the company where it's launched, and if it belongs to Russia or Belarus, then the files are re-recorded. So you can only have the files with hearts instead of your proper files. Some other issues: excessive access rights to the wrap, to builds, and build agents. Here we have a new staff member. There are many projects with codes, so the person is usually added to a group, having access to a lot of repositories. And this staff will not necessarily use or commit code to all of them. If an account like that is cracked, the threat agent can get access to all the reps. The code and the script in the build are usually in one rep, and this means that the code from the rep can be modified, and this way you can get access to the agents. If these agents have builds coming from different branches, including from develop and Visa, and then the code modified in the release branches and the artifacts which are built there in the develop branches. So apart from that, you will be able to modify the artifacts from the release branches. Solutions: use different build agents. Use container technologies so that when the scripts are modified, you don't grant access to the whole agent system, but rather to the container. Then, when you get access to the container, you won't be able to modify other builds on the same agent. Now Vasily, my colleague, will share with you the issues you might face using a TeamCity extension, which looks quite benign. Hello everyone, my name is Vaisa. I'm a developer from the Positive Technologies company. I deal with data pipelines, and I also develop Patrol 8, Mac Patrol VM, and I also develop services for standoff. So you've had theory before, and now I'll give you the dirty fact. So this is an example built on the abstract infrastructure you can find from any company, any startup, and so you'll see how it can be exploited. Let's go back to Zhenya's slide. Here is how it works. Let's imagine that we have an IT company. So we want to develop our product which will make money for us. Okay, what do we need for that? So we need to store the code somewhere. Now we have two versions. GitLab and GitHub. But I haven't heard a single example where GitHub would be used, because it has a lot of cons. It doesn't have the CI/CD, and well, I believe that GitHub is a must-have almost everywhere. Okay, we store the code somewhere. Then we need to have builds. To deliver the file to the client, we want the code to become an artifact. We are not going to send the code, and we need it to be deployed to the production server or the update server the client will get the artifact from. The solutions we can apply here: TeamCity and other examples. Usually, the corporate standard now is TeamCity. It's convenient, it has a clear quality of the code, it has good technical support. No advertising, by the way. What is TeamCity? It's not a black box, so we have some runners there. So TeamCity is a kind of a manager, and the code is built by the Unix and Windows machines, which are called agents. How does it happen? There is a command coming to the TeamCity, so build this artifact. We have the code from the GitHub to the runner. The runner performs the operations from the script, and then we have the output, the artifact. Then the artifact is either stored in GitLab or Artifactory or any other warehouse related to the update server. Then we can launch deploy with TeamCity, and the artifact we have will fly to the update server where the client can get it. Okay, we are a threat agent. Just imagine that. We need to crack the system. What can we do? This is a real case. A guy, a staff member, just shares the credentials. So maybe it's phishing, maybe he did it for fun. So the hacker gets into the system. So we can see what we have with the input. Okay, they scan the network, they see the services. So what do they have? They have access to GitLab. Okay, we have one project here, and we can have many. Okay, we'll take one. It's called a package scanner. Good. We don't have any credentials here, so we can only read it. We cannot commit any changes. We just have a look at what we have there. Okay, they can see the code. Nothing unexpected here. And this tick, this green tick should be mentioned. What does it mean? It means that we have CI/CD bolted on this project. Okay, we click it, we get to TeamCity. Okay, we have this first connection. The code storage. Okay, we have the connection between storage and building. We have two stages here. The idea is that the first stage is building the artifact, and the second one is deploying it. What shall we pay attention to? Number one. Raise your hands if you have dealt with TeamCity or are going to do it. We have introduced it. Okay, we have people like that. Good. We cannot see anything here. So we can see the sandwich to the right in blue. It means that the output will be an artifact, a downloadable one. And we have the run button at the build stage. So we can run the build and we can add something. Okay, at the deploy stage, we cannot do anything. We have no rights. We cannot influence where it will be deployed or introduce any changes. So we get to a case where we have minimal rights. What's our role with TeamCity? Let's have a look at the settings. We have asked our friends about the rights they give to the staff working in TeamCity. Here are the three major rules. Number one, run build. So the people can run build. So this can be developed branches, so they need to test what they have coded to see whether it works before the testing stage. Okay, then we have the project reviewer. This is the basic right to see the project. And we have the customized build parameters. Going back to the previous slide, we have the run and we have the three dots there. Okay, what does it mean? We can add parameters to the build and to deploy. Why do we need it? When you have deploy and build, you have some meta parameters like flags for build, some meta information of the artifact to be built. And at the deploy stage, we need to mention the IP. So without the customized build parameter role, we cannot just press the run button. So we can be very good programmers who can generate things in an automated way, which is not very reliable. Okay, we have 2 points of ingress. What can we do? Number one, the previous standoffs show that people did it this way. They try to find their ICE vulnerability for GitLab and to launch there some scripts which will try to exploit this IC. Well, you will be discovered and quite quickly, and chances are low that anyone is going to pull it off. People are trying to keep track of the versions of the software, and this is a so-so option. Another approach is looking for vulnerabilities at the production server. So after TeamCity, we see deploy, so we know where it is deployed. So we have the Unix or Windows host there. So we can try to find some zero-day vulnerabilities which are published, say, yesterday, today, or tomorrow, and we can hope to get access. Well, this is quite questionable. I don't know any statistics. I believe that it scarcely happens. And the third option is to use social engineer to obtain the credentials of those who have the right to impact the code or the update server. So we can see this case quite often. And here we rely on other people. We need a 100% option. It should work every time. We just press the button and hack everything. And the final solution is to try to impact the code at the build stage with the TeamCity agent. This is quite interesting. When the code is delivered to the build agent, if we can connect to the agent and if we can impact it, then the process when the artifact is being built can be altered. So this sounds nice, but the question is how we can do it. Okay, here's the scheme. We have Team Center in the center, and we have the build step. Okay, it goes to agent 1. So we can have a lot of agents. If one is busy, we can take that one. We can also see in TeamCity which agent is doing what, and this is an issue. So we press the build button, and so the command goes to the agent starts assembling the code. So if we are attackers, there are 3 ways we can impact this. So the first way is brute force. So you can try to crack the credentials and to get to the agent. This is difficult to do because there are some tools used now to protect the passwords. The second way is to change the outgoing data. Well, some say that HTTP is used for this process. They say why to deal with certificates and WAF and so on. So they send this traffic in a non-encrypted way. And if the threat agent has access here, so they can change the artifact or the code, the output code. Okay, it sounds nice. Okay, say our company is very well protected. They add HTTPS. Okay, then this will not work. And the third option is to impact the data in the build process. So we don't know how to do it, but this would be great. Okay, let's dig further. If you have the project viewer right, you can have the logs of some stages, the build stage logs and the deploy stage blocks. So you can launch build. So this gives you a kind of selection. You can see the final build, you can run it many times and save logs and find some trends. Okay, we have done it. This is a great company. They hard code the agents. So we have one build for one version and deploy for the other agent. So the hacker cracking one agent cannot impact the other step. This is great. Okay, we have seen it. Another important parameter is the checkout directory. What does it mean? Okay, everything will be around this parameter. This is really important. If we have one of the same step launched from the same agent, I don't know why they did it in TeamCity, then it will be built, the output artifact will be built in one directory. So we can see OTP, TeamCity agent, work, and then the hash. For some reason, they decided that building a new folder every time is too difficult, so they store it everywhere. So the hacker doesn't need to look for the directory, so they know where it is. So, okay, we have this box ticked. We know where the artifact is built and in which folder the output will be stored. Let's move further. The second rule. We can have meta flags for the builds. We click this three dots and go to the parameters. Okay, there we can check anything. So in TeamCity, they decided that they will not segregate the flags. You can say you just pick what you like and how they can exploit this vulnerability. We can interact and impact the environment variables. So we can say what should be added to the environment at the agent level. And Zhenya said a good thing. He said, okay, we can change the variable. So this is the Unix agent, so we can scan it, we can see it. Okay. If we change the press variable, we can add TMP. Okay, we can see the builds, so we can see what is run when the builds happen. So at the build stage, we can see that they start with a Py installer. Okay, this project is on Python, so we use the Py installer, so we compile the Python. Okay, this is the Py installer. Okay, what can we do? If we have access to the agent, so we break their credentials, for instance, then in TeamCity we can send the priority directory, TMP. What will happen? If we connect to the TMP directory, if we have there the Py installer file, so TMP will be ranked first. So when we have the command to build the binary in the Py installer, they will go to the TMP directory and they will find the file Py installer. We can record anything like Pasha's script in the checkout directory. It will record our artifact. So this is a great option, but we don't know how to connect. We haven't booted it. Okay. We put it in our folder, so we need a 100% option. So we don't want to brute force anything. So this is quite interesting. 2008 and 2016. In 2016, a guy was, well, invented. Maybe he was the one of the first, but we don't know. He published the exploit where they used the environment variables. So we can use the variable for Perl and receive the RCE exploits. Nobody paid attention. They said it's not a bug, it's a feature, and they kind of forgot it. We don't have Perl, we have Python, so how can we connect it? Okay, 2008. In 2008, many good things happened. Okay, I was in my second grade, and in Python, they had their modern anti-gravity module. It's there since 2008. It's in the basic images of Python. Do you know what it is? Well, I didn't know what it was. Indeed. If we import the anti-gravity module, it goes to the browser environment, finds your standard browser, and in the browser it opens the comic book. The developers tell us that the anti-gravity module will make your code fly, but actually it can make it drop. We have the Python warnings variable there. Do you know what it is? Well, the Python warnings variable is responsible for errors. So visualizing these messages. Here is the structure. So we mentioned the action at the beginning, then the message, the regular message to process the mistake or error, and then line. Well, if you go deeper into the code, this is a CPython screenshot, latest version, 2 days ago. And here you can see the category processing function. What does it do? It checks, okay, if in the category we have a dot, then it will import the built-ins. Well, if it doesn't have the dot. If you have the dot, then it will import the module. Well, it sounds scary. If you have the dot in the category, and if we set the malware module, it will be imported. Okay. In theory, we can import anything. Okay, we decide to import the anti-gravity module. What's good about it? Well, it will launch the browser in an automated way. It goes to the environment variables. So we can say this. In the browser, you can say Perl thanks variable. And we kind of connect the Perl feature or vulnerability with Python. Do you know what Perl thanks is? Okay. In almost all the Unix systems, we have Perl installed. It is there in the origin, binds and so on. So in Perl, they add Perl thanks. This is a tool to open feedback, like guys, it's good or otherwise, and some proposals and feedback. Okay, so in the browser we say Perl thanks, and Perl 5 ATP. This was taken from the exploit of 2016, and there we show the directive mbase sprint. Then we can have some sh command and exit. So this is the payload. The sh command can be anything, like id. What will happen? As soon as we try to import or launch Python, it will go to the Python warnings variable. It will try to import the module anti-gravity and the X model from it. This will generate an error. As soon as an error is generated, I will try to import the anti-gravity module. Anti-gravity will go to the browser variable. The browser will go to Perl. Perl will go Perl 5 OPT variable. Perl 5 OTP has the payload. The payload is run, and whatever we launch in Python, we can say Python 3 or Python 3 and a script. Anyway, we'll have an error, and this will run the payload. When we Googled it for the first time, we were surprised to see that it hasn't been fixed. Now we will tell you how to exploit it. Okay, we are a guy without any important authority here, so the customized build parameters. We say that we want to change the virtual variables, and here we pick the browser, Perl 5 OPT, and Perl warnings, and we run it. The script of the payload has the id command. Okay, we have built. Then we look at the logs. When the code is loaded, the PyInstaller is loaded, then they use Python, and okay, we import the anti-gravity module, it loads the payload, and it's not Python running anymore, it's our payload running now. So we have the root at the agent. That's nice. What can be done here? Okay, people can say this is Python, so this is not interesting. You just invent it. It's not used in real life. Haber has a good article on this. We used it for this research, and there we have examples for Python, for Perl, and so PHP and Node.js and Perl, the 3 languages which have this vulnerability. If you have a project to use with TeamCity or any other automated, so if we use this data, this vulnerability is important to you. People can say, okay, you just launch the Python with the code, but we don't do this, so we have the Docker. Okay, if you change the virtual with the host, it will not go to the Docker. Okay, we didn't find a way how it can be exploited. But here we have a small trick. People don't like launching Dockers like Docker container. They just send instructions and everything is built there. And here is another click. I mean, the Docker Compose uses Python. as soon as you launch it, it calls Python. Python calls Python warnings variable. Then it calls the payload, and it is run. And with the build agent, we can see the Docker compute command. We wanted to see the version, so we have the python run, and we get the root issue. This is dangerous. We send it to the developers of TeamCity, so they told us that this was a feature, that they would add a comment to the document, that it has to be fixed, but this is a feature. Okay. How to protect yourself? The instructions have been mentioned by Zhenya. Let me just reiterate it. Use different agents for different branches. Here you see an example where the steps were split by the agents. So we had Python, we had build and deploy. Ideally, the production branches should give access to no one, just the top management. And we have the develop branches run by different agents. So if they hack your agent, it will not impact the production branch. So in this case, the worst thing which could happen, we have the develop and production branches built by this agent. So if the threat agent gets to the agent, then you can try to have the production branch send it to the client. It will go to the agent with this branch. Then the payload will be run, and the update will come with a payload. And everything was shared through, so everything should be shared by HTTPS, and please segregate rights and stay healthy. Thank you. Thank you very much. I have a question to Evgeny. What is the most frequent attack on the supply chains? Usually it's independency confusion. It's easily pulled off, and you just know the title of the dependency, you load it to the public repository, and that's it. You are done. If this vulnerability is there, then this payload will run. Have you seen it in practice? Yes, we have. Hello, my name is Victor. Thank you very much. A recommendation to protect from this issue is not to use some shared runners. This is a good recommendation in general, but we have some subtleties here. Okay, say we have a big company, 100 developer teams. The teams don't want to support their own runners, and the infrastructure today is, well, the less you use it, the better. And in companies like that, they primarily use shared runners for all the teams. And we have the test environment and the prod environment. So the question is how to deal with it. How to deal with it if you use shared runners. So number one, you can provide the GitLab runner as a service to the teams. Another option is to segregate the two segments. What would you do here? The recommendations we sent to JetBrains, we told them, guys, you can impact the customized build parameters. There are too many things there. You can let the DevOps say that, okay, we can use these flags and they can be hard-coded so that you don't change the environment variables or anything. And they said that this was a feature. So this is the easiest way. Well, what can we invent now? So we can just strip every one of the customized build parameters. You can have an under-the-hood script for TeamCity to hard-code everything. And this is not very optimal, but maybe you'll be protected that. So this is what I would recommend. Well, this could cause problems, but it will make you more secure. Okay, containerization is an option. If you use a container, if the build is done by one runner, the adversary will not be able to get out of the container to further modify other builds of the same runner. But you can clean the runner following the build. If the package is built well on a naive system, so well you just build the command, then you clean or purge this run, and when you build the other one, it's used for it. So you don't have any credentials or everything. Well, okay, you don't have the credentials there. But if you have the LPE there, or if you have a privileged account used here, then they can provide another library or binary, and it will be difficult to get rid of it by cleaning. Thank you, colleagues. My name is Ilya. So you have said that the artifacts can be brought to one place, and you said that it's not good. Okay, how can you do it in any other way? Say we have some standard access segregation, and we have the standardized agents, so they're recorded to one place, and then they're further distributed. So the question is, what's wrong with this approach, and how we can improve it? Okay, the build is happening in one place. Then the artifacts are sent somewhere, either to the artifactory or to some other storage facilities or warehouses. So we know the directory where the build is going to happen. This is not very good. We can randomize it. Thank you. Thank you very much. Usually we don't have 3 or 5 agents. How do you manage agents in positive? And how did you cover up positive? Okay, this is not from positive. Not exactly. We're not going to share how we're doing it in positive. This example is kind of abstract. Well, it is not exactly abstract. Well, cases like that are happening. Well, the example with the 3 agents is abstract. If you have more agents, it will be more difficult to manage them. Okay, then the question is how to manage the agents to avoid a scenario like that. One of the recommendations was to hard code or to segregate the stands, but if we have more than 1,000 agents, for instance, we cannot hard code the agents for build of dev stands or prod stands. Okay, I've mentioned that. Okay, going back to the previous question, if we know the directory, so maybe we can segregate access so that those who need it should have access to this folder, and we should ban any change to this folder. Well, it's not about having access to this folder. I mean, access to this folder is connected to the account which makes the build. I mean, humans shouldn't get there. We segregate access if we remove the builder from this access list. So we only have the root and the build agent. So only them have this rights, and we cannot further segregate it. What about banning changes? And how will we build in this folder? Okay, there we send the code, and the output artifact is also there. And if we remove the change rights from the build agent, then we'll have issues with the build, so we'll not have any artifact. And there we have the code, which goes there. Okay, thank you for your speech. This gives us food for thought. Okay, you said the dependency confusion is the easiest way. Okay, we have calculated the SH 256, and so we check all that. Can you go around it? I mean, so we have downloaded this, we have checked the SH. Okay, then we'll do it if we match it. Otherwise, we just destroy the build. Okay, and then you will modify the libraries. Then, in any way, you will need to enumerate SH. Okay, this SH should be stored somewhere. Well, to hard code a version is something you cannot do, since you'll have this continuous updates. So you need to store it somewhere, and this brings more costs. So this is healthy paranoia in a way. Yeah, you can just make sure that the build agents don't take the packages from the public reps. And in the private rep, you can have a caching repository. Thank you. Thank you. Then you need to pick the most interesting question. Thank you.